So you have basically a Swiss Army knife, but you need to know how to use it to make this technology more accessible. This is something that is unique.
Welcome, Anas. Thank you that you are open to have a talk with me today, to give the audience some insights of what we are doing here at Forget. Maybe first you can start to introduce yourself so everyone knows who you are.
Thank you for having me. So I'm Anas Moalem. I am here at Forget leading the process development team. I joined Forget in 2013 approximately, and since then I'm here and happily contributing to the developments in laser processing.
Yeah, okay. Let us go one step further back in time. What did you learn before starting to work at Forget?
So my background is mechanical engineering. I went to RWTH Aachen University, studied there, came in contact rather early with laser technology through the lecture of Professor Poprave at that time. And from that time until today, the enthusiasm for laser technology has been with me and present all the time. So yes, this is my background, and after my graduation, I went to Laserzentrum Hannover and continued there also with laser technology, with R&D work. The Laserzentrum Hannover is a non-profit research organization.
Yep.
And my work over there was in laser microprocessing, and I spent around 7 years there developing different processes, working also closely with customers.
Yeah, yeah.
I took the opportunity to do my PhD thesis over there, and some also very interesting work which involved spaceborne lasers, designing mechanical design of spaceborne lasers. Yeah, and that was my time over there, and then I came to Forget.
Yeah, so the topic was already quite the same. How did you come to Forget? So did you know the company before because of your work in Hanover? Why did you take the decision to start here?
Well, so I knew Forget from before. Actually, yes, we did some research for the company. Jörg came to us with very specific questions, and we did some work together. So I knew the company already, and since I'm originally from around here, from Aachen, I already put in the back of my mind to maybe come back to the region, maybe work with Forget.
Okay.
But actually also I think the character of the company was rather interesting for me, being a small company, a quickly growing company.
How big was the company when you started here? How much
I think
people?
it was somewhere below 100 people. When I finished my work in Hanover and realized I want something new, actually the reason why I wanted to change was the nature of public funded research institutes, where you come up with many innovative ideas, but your mission is to contribute to the knowledge, to the public knowledge, and to help industries and write research papers. So you generate knowledge, but the work ends there usually, and all the commercial aspects, the benefits of those new ideas are taken somewhere else.
So that was a direct decision to say, I want to leave this more scientific area and go to a corporate company area. Was it hard to change your mindset so you can fulfill the differences? Yeah, from the scientific view, just running and researching, and now you must reach targets in a definite time. Was that a hard switch for you in your mind?
Well, the only difference is that with Forjet, everything is quicker. It has to be quicker, but also we have the means to make it quicker. Mm-hmm. So we have quite good financial situation here, but also the targets that we get are more challenging. So that's pretty much the main difference between my previous work and now. Other than that, working towards customer specifications, achieving goals at certain dates and so on, this is something that you have also in the institutes as well.
Okay, I see. So let us go into more detail about the task that you mentioned. What are the typical tasks on your table along a week? What are your responsibilities, your daily work like?
So me and my team are working on developing new laser processes as well as improving existing laser processes. Mm-hmm. And our focus here is cutting of glass with lasers as well as laser patterning, and this involves removing thin film coatings of plain substrates.
Okay.
So we develop new processes, we improve processes, but we also work on specifying the optical setups. So we come up with qualified components and the arrangement of those components. Yeah. And supply our engineering department with these informations to build up our machines, basically.
So, everything around the laser process is itself, as I understand you right. Yeah. The machine optimization is not in your scope.
We contribute, yes,
okay.
but this is together with the other teams in the engineering department, software and mechanical engineering as well.
Yeah. Okay, Anders, now I understood you are really experts of laser and how to work on material with laser. You are much working with and on glass. Tell me, why is the laser a good working tool to work in and on glass?
Laser as a tool basically is weightless, so this gives us some immediate opportunities. Since light does not have any mass that needs to be moved, we can move this tool basically anywhere we want with very high speed, and the limits here are basically only set by the motion system that steers the laser. Yeah. So if we take laser scanners with small, fast-moving mirrors, then this is the limit, or machine axes, they don't need to move big masses, basically. And this is the immediate benefit of the nature of light, but also we have the fact that laser sources today give us the possibility to set the laser powers very flexibly, and the laser energies and the laser pulses and so on. We have access to many process parameters that we can tune for each and every application. In return, we get basically a Swiss Army knife, but we have to know how to use it. This is where we work on in our team to develop the processes, and the benefits go further. The benefits also have impact on the engineering side, and ultimately also benefits for the customer. What is most interesting for our customers is the possibility for very high yield in the production of our customers' applications, high degrees of automation, and all this leads to becoming more competitive on the international market. So our customers also in high-wage countries have the chance to use the laser technology to become more competitive.
Okay.
And one additional aspect is that laser technology has already reached the minds of the designers of the products, not only the fine arts, but I mean the designers, the physicists and the electricians and the
people who design products.
Exactly. They already know there's laser technology. They can utilize it, and sometimes we see products that are only feasible using laser technology. You cannot produce those products with traditional tools.
Yeah, okay, interesting. Yeah. Regarding the working on glass, there were some points missing. That's why I will ask about, I believe some people will wonder, glass is invisible for light, yeah? The light is shining through the glass. How can you cut the glass with light?
Yeah.
Maybe you can explain for a regular guy.
So yes, you are correct. Actually, we do use laser radiation with the wavelength that usually is transmitted through glass. But we also make use of certain physical aspects. There is something called nonlinear absorption, and this takes place when the laser radiation intensity is very high. So what we do here is we focus the laser radiation into the glass or into the material that sits on top of the glass. And because it has high intensity, it is ultimately absorbed. So the energy is actually deposited into the glass. And we, of course, have different approaches depending on if we're using patterning or cutting or something else.
As you explained it, it sounds really easy. That means it's a machine, you place some piece of glass and then you can very fast cut it in any shape.
Sure, everything's possible.
Maybe you can explain what's the complexity. Yeah, I know you have so much different parameters you use.
Yeah.
So what's the complexity when you want to cut the glass?
Maybe I explain quickly what's happening when we cut glass. So we utilize the laser radiation to introduce modifications in the glass. So as I explained before, we make use of the nonlinear absorption.
Yeah.
And here we have one special aspect which is called Kerr effect or self-focusing. So this is a phenomenon which happens only with high powers or high laser intensities. Every material, transparent materials especially, have refractive indices.
Yeah.
And usually a transparent material has one value for that across all the volume. But in the presence of high energy laser radiation, the refractive index changes.
Okay.
So if the laser radiation has a distribution across this material, we also get a distribution for the refractive index. And this in turn behaves like a lens. But this lens is only there because the laser radiation is there. So this is something fascinating.
Yes, self-focusing, as you said.
Exactly.
Yeah.
So we use also our laser cutting optics, which have lenses, but the glass that is to be cut also introduces a lens effect together with the laser radiation. And the result is a very small modification, which is much smaller than what would be possible with normal lenses.
Yeah, in numbers?
Yeah. So the modifications that we introduce have a diameter in the range of 2 micrometers.
Okay.
And interesting here is that by choosing the correct optics beforehand, we can have this modification elongated into the glass material. So we have basically a 2 micrometer diameter modification, which has a length in the millimeter range. So if we compare units, micrometers on one hand, millimeters on the other, we have a factor of 1,000 difference, which is quite a big aspect ratio here.
Yeah, definitely.
So this is one modification in the glass. But for cutting, we arrange a multitude of these modifications next to each other along the desired cutting path. And in the end, we have this contour, which has a multitude of these modifications, and we can introduce an additional processing step, which can be mechanical or another laser step, to separate the glass at this exact.
Okay, so the two parts are still sticked to each other. Are not.
Exactly. Those modifications, you can call them also perforation. Maybe you know a paper, when it's perforated, you can separate it. And it's the same with glass. It's actually also called ripping. We rip the glass at this location. Okay. And so the parts that we get out of this have the exact precision which was used for introducing those modifications. So we can use the full potential of our machine and its precision. And this reduces the following steps dramatically. So usually glass parts need to have grinding and washing steps and so on to get to the final shape. And with laser cutting, we are at the final shape coming right out of the cutting machine.
Yeah, okay, I see. So I know this kind of glass cutting technology is a quite young one in the industry, industrial machines. I know it's maybe like the water jet cutting was for 40 years ago or something like that. Can you tell me something about the current limitations? Yeah, what is possible up to now? It's young. I'm sure there will come more. What's at the moment the status?
Sure. Well, so some of the benefits and advantages of laser cutting are also at the same time sometimes disadvantages. For example, when we cut glass with laser, there is no cutting curve, so no material is lost. This is an advantage, but at the same time, if you have, for example, a closed contour, for example, we want to cut a circle, then this circle, even if it is separated from the rest, we cannot get it out because there's zero gap.
Okay.
So we need to do tricks here. We need to introduce release cuts. And other limitations, well, of course, laser technology is a little bit more expensive than water jet cutting. But customers need to weigh the benefits. With water jet cutting, you have the water, you need to recycle it, you need to wash, and so on. With lasers, you have other.
Is there a limitation regarding the material? There are different kind of glasses. You can have colored glass or maybe just dark glass.
So the glass type also plays a role, of course. There are glass types that are a little bit more difficult to cut, especially those types that have a low thermal expansion coefficient.
Yeah.
Like, for example, fused silica or borosilicate glass. Usually those modifications that I spoke of can be introduced into all of these materials as long as they are transparent. The step that gives us difficulties sometimes is the separation. For automatic separation, we depend on the second laser step, which for that we use the CO2 laser. We introduce local heat on the glass and make use of the thermal expansion locally, and with this we separate the glass. But if there's no local thermal expansion, we cannot separate. So this does not work for fused silica. Borosilicate glass is a bit dependent on the shapes that we want to cut. And the easiest and most common glass is the soda lime glass. And somewhere in between we have also the aluminosilicate glasses. And this is really depending on the exact material, the thickness. And for that we recommend doing tests. So materials like this we would test in the lab, and according to the customer specifications, and then we can say exactly what to expect.
So your main targets are developing new processes, find new solutions.
Yeah.
Regarding that glass cutting topic, maybe you can mention two most interesting topics you have in mind. What was the last really cool step that you and your team made possible with the machine, and maybe what do you think will be the next development step to, I don't know, enable a cutting shape or enable fused silica to cut?
Well, so a rather new or young experience that we made was something that we did not expect was possible. So increasingly in transportation glass, the material is not completely clear, but it's tinted. So tinted glass is used almost everywhere in transportation. Yeah. And we have glass types with different transmission degrees. And there we were able to cut glass which only had 20% transmission. But we were able with some tricks to still cut this type of glass. Yeah. This is something that usually is not that easy.
Okay, can you give us maybe also an insight on your development of the future? Is there any interesting topic you are allowed to mention that you are working on?
Well, of course, we are working on different aspects to make this technology more accessible to more customers. That involves, of course, enabling cutting of difficult materials like borosilicate glass.
So wider range is...
Yeah. It also involves cutting more complex shapes like inner contours. And some aspects that I am not able to speak about, but are exciting for the next years.
So Anas, I already mentioned this kind of technology to cut glass is quite a new one in the industry. Give me your vision on this technology. Where will the technology be in 10 years, in 20 years? What will be possible?
So I think the current limits simply will be pushed further. The glass thicknesses that can be cut will increase, basically. The speeds will increase and so on. But also I think, because this is in all technologies the case, that the components will become more cost effective. So for example, the laser sources as a main factor, and this will enable, of course, lower costs for the machines, for operating the machines, and hopefully we will be able to introduce those machines also to a wider range of applications and for more customers. Because today the correct application, or the application that where lasers are, where they make sense,
Yeah.
are those products that have a certain value. So glass products, for example, with a certain coating, or that provide a certain functionality, like display glass, or
Yeah.
in the transportation sector, the windshield that has certain coatings to block sunlight, but at the same time transmit sensor signals or mobile phone signals. So today those are the applications, but with the technology becoming more accessible, I think we will be able to offer solutions for a wider range of products, maybe home appliances, maybe a wider range in the architectural market. So that's, I think, what's going to happen.
Okay, I see. So let's move further to your second topic you and your team are caring about, which is patterning, or if it's large area, decoating maybe.
Yeah.
Maybe you can just give me an open insight. So is it more complex than glass cutting? What are the difficulties?
So laser patterning, what we do in Forjet is laser patterning for photovoltaics applications, or for smart windows, transportation glass. But what do they have in common? We have a substrate which is big, and this substrate, for example glass, has a thin film coating or a stack of several coatings, right? But those coatings are usually applied on the whole surface. The function of those coatings, however, is only provided after we remove it at certain points. So for example, in transportation glass, we need to remove certain parts of the coatings to enable cameras and distance sensors to look through.
Okay.
Also for mobile phones to be able to communicate to the outside. As well as if you take, for example, touch screens, these are made also of transparent materials, often glass, and there you need to pattern basically a conductive circuit, basically a circuit board, but you only cannot see it because the coatings are transparent. But there you will have basically a system of circuit traces. And this is what we mean by laser patterning. This is what we do basically.
It sounds in general much more complex than glass, because different layers, maybe different stacks of layers. I expect every customer has different requirements on precision, on cleanness and something.
Yeah.
Is there anything in your mind what you can mention? What was the biggest step in the last 2 years that you could enable with your team?
For that, we have to know that the machines, yes, they are rather complex depending on the application. So there are applications, for example, the laser edge deletion for photovoltaic modules, where the machine is rather simple. But in other applications where we have large substrates made of thin glass, it's hard to imagine, but thin glass, which is large, it also bends very easily.
Yeah, sure.
So to maintain the precision there is a challenge, especially there if we have smart windows, or if we have grids or circuits that need to be applied to the coating. We need to maintain very high precision in the single-digit micrometer range.
Okay.
And for that, we developed a machine platform called Topaz, which is equipped with several laser sources and several laser scanning heads. And laser scanning means that we use devices that steer the laser with small mirrors very fast. But we have a multitude of those laser scanners, and they process the glass simultaneously, but also at the same time we move those scanners across the glass.
And the precision between the scanners is single-digit micrometer, you said? Oh yeah,
Exactly.
crazy.
So we need to maintain basically the matching between each laser scanner, the matching between the scanners and the machine, and the matching towards the substrate as well.
Yeah.
And this is quite a challenge, but this is something that we have been working on for the past years. And yeah, we are there. We have achieved it. Of course, development never ends, but we have quite a good situation now.
Yeah.
Also, what is important here is precision alone is not something quite new. It's only special if it comes together with speed. And we achieve this precision with astonishing speeds currently.
Yeah.
For example, what I mentioned, the single-digit precision with several dozens of meters per second scan speed.
Yeah.
So I think this is something that is unique currently.
So Anas, tell me, what was the last big achievement that you could reach with your team? Do you have something in mind directly?
Sure. So I think the most recent topic that we worked on, and across my team, also with other teams in the company, with the software engineering and the mechanical engineering teams, was a topic where we improved our Topaz patterning platform. So this machine is equipped with several laser scanning heads and several lasers to enable fast and precise patterning of large glass substrates with coatings on top.
Mm-hmm.
And the special aspect here is that when having a large glass substrate, and in this case it was rather thin in the millimeter range, glass is very flexible if it's that big. So it is flexible, it can have different shapes when it's in the machine. And when we want to reach precision on such a glass piece and processing in parallel with several scan heads that need to be matched in between and matched towards the glass and matched also towards the other kinematic systems, this is a challenging task, and we needed to work very close together, an interdisciplinary team inside the company, but also very close exchange with our suppliers, special scan systems, special lasers, and also special kinematic systems. So this is something that we've been working on for the past years, and we have maximized the output and have, I think, the fastest, most precise machine currently available on the market.
Yeah, okay, crazy. Yeah, it sounds really like a complex challenge, and yeah, that this machine brings a new level to the machines at the Forjet Group, I have the feeling. Give me your view on the future. How do you see will the development be in the next 10, 20 years regarding this patterning topic? Are there any interesting parts that you are already working on, maybe?
Well, of course, me as a technical guy, I'm mostly excited about the technical stuff which might be too far, which I cannot really talk about. But I think what I can say is that we are working on further pushing the limits in terms of precision, in terms of yield and monitoring, and giving more features for the customer to have highest throughputs, highest quality, and this is something that is important for future products that today might not be on the market yet, but will be in the future.
Okay. Let me move to a topic around your team a little bit, because I think you spend much time to think about about laser processes. Yeah, you have the customer requests, and you already mentioned that that's a core task of you and your team. In preparation, I thought about what could be typical problems if you have so much people that are looking for solutions and searching for solutions. Maybe you have good answers for that. So I do imagine if someone wants to find a solution, it's easy that you just run and run and run, and then the weeks are running, the months are running,
To lose
you
yourself,
just
yeah.
lose time. It's
Yeah.
not effective. Is that a real problem? How do you handle this if it is?
Well, it can be a problem, certainly. So every one of us in the team, we are all enthusiasts in this field,
Yeah.
and we like to solve problems. Sure, sometimes if it's a big challenge, we sometimes still try harder. I think there's not a general approach for that, but you have really to look from case to case.
Okay.
And decide on that basis. Sometimes to be resilient and push further is okay. It's actually it depends on the application and the customer. And if we believe in the solution, if we believe there's something to get there. But I think the team members and me, we are all also practical enough to say if it's not feasible, if we think it's enough, then also we find a good stop and discuss with our customers or with our colleagues possible ways around the problems, possible solutions to reach the goal.
Yeah. Okay. Another thing in my mind is your work is to develop knowledge. Yeah, to find something out, to find solutions. So now you said there are so much differences. The customers have different requirements. The layers are different. The layer stacks are different. How do you ensure that you do the same task not every year? So how do you save the knowledge and can guarantee that you do the work not twice?
Sure, that's a big task, and it's always improving. So for my team and me, this knowledge generation is basically, our knowledge is our currency, right? If we don't maintain our knowledge, we lose the value of our currency, right? So it's very important. We have a strict documentation policy. We need to document everything. We have a paperless policy. We access our database from all the computers in the company, and we come back to this every time. So usually the experience of our colleagues already enables them to look at the correct place in the database. But this often is not enough. We also need to be able to get the information out, and there are possibilities that have been created in the last 2 or 3 years to do that. But it's a big topic. It needs to be maintained.
Yeah,
absolutely.
But it sounds very structured.
Yeah.
Yeah. Okay. Yeah. Thank you. So we now spend some time about cutting and patterning. Is there any other process you want to mention? I'm sure customers coming with every process.
It's a balance between focusing on what we are strong at and also sometimes looking left and right towards new topics as well. So our main work is actually focusing on what we are strong at.
Yeah.
We have, of course, now our colleague Klaus, which leads the business development team, bringing us new ideas, new applications, and so on. And we decide together which one is worth looking into.
Mm-hmm.
But this is something we don't like to talk about very early. But sure, there are trends in the markets. Everybody knows about them, but we cannot. We cannot follow every trend. We have to focus also our resources on what we can achieve with our teams. Yeah.
Okay, thank you, Anas. I want to close our interview, as I did it with the other colleagues, by asking you for 5 buzzwords regarding Forget. What do you get in mind?
So I think one buzzword is challenge, fun, success, and together.
Together?
How many was there?
4.
4. Okay, laser.
One more?
Obviously.
Laser, yeah, okay, that's easy. Okay, thank you.
Welcome. Yeah.